So this is the first of our afternoon seminars, and let me introduce you Dr. Professor Suzana Gotovac-Atlagić. Did I pronounce it correctly? Okay. Suzana. I call her Suzana, that's enough. And she will present this short seminar on modern application of European mineral resources in nanotechnology. That's really interesting and very up-to-date seminar. Thank you, Suzana.
Thank you, Silvia, very much. My dear audience, thank you for coming. We are a little but selective team, and maybe it sounds unusual to talk nanotechnologies in Balkans. Yeah, but it's a serious story of me and my colleagues, of course, at University of Banja Luka. So I hope you will enjoy a few words about it. I will keep my presentation at about 15 minutes, I think, isn't it? So let's start a little bit. For those who don't know, Bosnia and Herzegovina is very near to Italy, just across Adriatic Sea. It's a little country, but very diverse in mineral resources, which makes it so suitable for nanotechnologies as well. Banja Luka is our city. As you see, it's on the northwest. So, just a few words. This is our faculty, a fancy picture of it. For those who might come to study to Banja Luka, you are very welcome. We do have an English program for students, and you can spend 3 months preparing and learning our language if you would like so. So these are just the departments that we have, and you can choose. It's just next to the national government, so it's a beautiful location with a beautiful park very nearby. So this is chemistry department. These are real students. These are not Googled pictures. So these are all my real students, some lovely pictures of them working on the equipment. And you see what do we educate them. And as you see this data, 90% of students remain in Bosnia, which is a very good number, and we are proud of it. So this is showing that chemists have a job in Bosnia. It's meaning actually that our industry is really recovering and developing very fast. So this is the structure of my presentation today. I will tell you a little bit why international collaboration and exchanges are so important. And then I will tell you what is this material crisis story about, because all this project about RM at school also came out from the story of material crisis, raw material crisis in particular. And I will show you 2 examples of very exciting nanotechnologies that we are working on recently at Banja Luka University, so I hope you will like them. Okay, so importance of international exchange. I'm not going to be boring here, so I'm going to show you some funny pictures. You see me younger and probably lighter, about 15 kilos less than today. But I'm still happy, the same happy girl in these pictures. And you can obviously guess that I had the privilege to study in Japan. I spent 5 years and a half in Tokyo under a wonderful professor, where I obviously learned nanotechnologies. So this was a beautiful challenge coming back to my home country, where I was practically the first engineer of nanotechnology, not only in Bosnia, but in the whole of Balkans. So it was quite also a responsibility for me in the future, and I've really enjoyed that role to teach my students this important subject. Of course, you see that I have been enjoying the international exchange, and I think this on these pictures, you don't see the photos from my university time, but from my life with my host family, with my Japanese friends, and it was very important and motivational for me to study hard, because I was well accepted in a society. Yes, I speak Japanese. I know 1,800 letters, but this comes with it. I needed to learn it to study chemistry seriously. But it was not a big deal. I mean, I really enjoyed the hospitality of Japan. But after coming back home, there was a reality waiting for me. Obviously, from the first pictures, I had to get married immediately. Otherwise, my parents would be totally disappointed. So I did meet a very nice papa of my children, Mr. Milan. And we do have a normal and happy family life at home. And I'm really always proud to say that Bosnia is having a very good tradition of excellent kindergartens. So our children are guarded for 8 hours. They are safe in kindergartens. So I, as a scientist or any other mother who works in the industry or anywhere else, can really dedicate to the work. So this is why I enjoy the science, and I'm a mommy of 3 little girls. Some of them are big now. So let's talk this material crisis, which is a very serious subject. And from this story about material crisis, also the RMED schools project have started. You know, you heard that from Madame Armida. Okay, we have to preserve the sustainability of European material chains, raw material, what's going on? So what is actually going on? The problem with material chain in Europe is the fact that Western Europe in particular, we must say European Union, has mostly abandoned mining. You know, you have stopped mining. So it was good at the first time because, okay, we said, yeah, we're happy, we have ecology, we have environmental protection, very nice, we will close all the mines and we will be happy forever. No, you're not going to be happy forever. Now you are paying to the Asian countries or to Australia huge prices for some important raw materials that we need in Europe. So this is the reality. We have to be really cruel about it. And recycling is wonderful, but you cannot recycle everything 100%. So you will still need raw materials, of course. I love recycling as well. I don't just love mines. But this fact about preferring the environmental protection instead of mining has led European Union to the problem in material chain sustainability. You know, not only that we don't have material, you don't have materials, we have in Bosnia. So not only that European Union has problem with materials, but you have problem with the qualified staff. There is a very small number of mining engineers, of excellent geologists, and even technicians who would work in mine. Even if you have a magic wand of Harry Potter wand and say, okay, now we open 100 mines all around Europe, you don't have staff to work there. So that's a large problem. It's a 20 or 30 years of gap in education of young people in material sciences, as we say, mining, geology, and of course chemistry and chemical technologies. But the good news is that Bosnia never abandoned mining. I am very naughty and happy about this fact because we have 8 centuries of completely continuous mining and education of young staff and students in this area. So the idea is now for us to spread a positive message of what happened to Bosnia. You most probably do know that we have some unfortunate history. We did have a terrible civil war 30 years ago. But even after the civil war, Bosnia recovered just like that. I mean about the economy. So economy recovered very easily because we do have so many resources. We still have our mining going on. And at this moment, mining companies are so strong and so hardworking that the average miner in Bosnia has a salary like I do have at the National University as a professor. And I'm satisfied with my salary. So I'm happy for miners to have a good salary. I have good salary, they have good salary. So this is beautiful news. So these are some good salaries, people are motivated to keep working, and in some mines we have people who are 5th, 6th, 7th generation of the miners. Not to talk about especially engineers and people who deal with it. So it was very good for us. It helped us to recover from the crisis time. And this is just a selection of minerals, which of course you can see at our stand on the fair here nearby. So let's check a little bit, not just the mining. My story about nanotechnology today is going to be also about the tailings. You know, tailings is a sludge, a garbage that becomes available after the ores or mining resources are processed. And there is a lot of these. These are some pictures from around the world. You can find tailings everywhere. So they are becoming more and more interesting because even though Bosnia is also, of course, someday going to spend all of our mine resources, so we will also have to rely on the tailings and all of the world as well. So what can we use tailings for? There are all different kinds of metals, especially metal mining tailings are interesting because you can relatively easily recover, extract the metals from them, but still there is a lot of research needed in that area, and this is where we go. So we had a really wonderful pleasure this summer to host our students from Italia with Professor Alberto, who were with us, and we took them to the iron mine in Bosnia. Iron mine in Bosnia is the largest one in Balkans, not in Europe, but on Balkans, yes. And it is a strong international company. It's called ArcelorMittal, the second largest steel producer in the world. And you see the realistic picture. This is some of the visits of us with our students there. And although the mine itself looks quite not so environmentally friendly, but nevertheless, the mining system is really so good and the water is completely circulated. So actually there is not much harm to the environment in the sense of water and particles. Of course, we have to dig a big hole, but nevertheless, this hole is going to become an artificial lake and it's going to form a completely new ecosystem later. So this is good, very good practice in mining, it's possible. And why is iron still so important? Iron sounds like something ordinary and usual in our lives, but it is still very, very important. It is, maybe you don't know, but it is the most recycled material in the world. Iron and steel can be recycled endlessly, doesn't matter how many times. In average, even today, every steel contains some percent of recycled iron or the steel, usually about 20–30% or so. And sometimes in electric furnaces, which are the strongest one to recycle them, even 100% of recycled, this rusty old iron can be converted again to the superior steels. So this is very, very exciting news about iron. And when we come about, okay, I don't want to sound like a person who doesn't like ecology and environmental engineering, but of course for environmental engineering and clean energy sources, again, you really need a lot of iron in all of these technologies, especially solar panels or wind turbines, as you can guess. So iron is really important. Here are just some little snaps from the recent papers about other applications, not so technical, not so metallurgical, but chemical applications of iron, which are also still very important, especially in the area of catalysts. So why catalysts? Catalysts because catalysts, when you use catalysts, you reduce the need for energy in chemical industry. And energy is everything. If energy is expensive, as you can now experience because you don't buy gas from one cheap location, I'm not going to say which one. And we do buy from that cheap location, so we are fine. And we still produce a lot of energy, especially hydro energy in Bosnia. So if you use catalysts in the process, the energy becomes less necessary and the process becomes much cheaper. So this is one very excellent news about us, is that Bosnia is completely self-sustainable in terms of iron. I think we might be the only country in the world in doing so. So we produce all the iron we need for all purposes, especially, of course, for construction, etc. So we do have this large iron mine, which I've shown, and the steel plant, which employs over 2,000 people. And still, I was very, very curious about this tailings problem. Tailings. Bosnian mine also has a tailing, of course. It's like an artificial lake full of sludge, brownish sludge. You can see the images, how it actually looks. These are my students, Dragana and Marco. So we were like, okay, let's check what is inside. What else can we find actually in the mining sludge, in tailings? Remember the word tailings. So we tried to actually purify it a little and did the analysis, and of course, as you can guess, we found still plenty of iron which could not be extracted immediately. So we said, okay, if there's so much iron, let's first remove the iron and then we will talk about potentially other metals. We do find traces of lithium or something like that, but you cannot produce something if it's too expensive to extract it. So we stuck to the cheaper one, but this is, so to say, relatively speaking, cheaper one, because iron can also have a good price in market if it is produced as a nanomaterial. So, we try to make nanomaterials. You see our extraction process. It's just a simple laboratory procedures, just done with care and concentrating a lot. So we were really able to get good concentrated solutions of iron ions and make some very, very nice nanomaterials using so-called microemulsion methods. I'm very good in this. I learned this one in Japan. So we are just making different variations to have our original method in that. And we really, really obtained some very nice samples, which were, as you can guess, analyzed in Japan as well, because I like to involve my former colleagues from the study time. And we found out that we really were able to produce some very high quality materials. Some of them, for example, like this middle one, highly crystalline hematite with carbon shell. This is our sample produced 100% from the waste from the iron mine Omarska. But this is an exciting material because there was 11 papers at that time which were telling that this kind of nanomaterials can be used as a node in the lithium batteries. So always we come to lithium. We do hope that sodium will replace lithium, but nevertheless, it's good to have as ecological components in batteries as possible. And of course, hematite is so harmless that you can eat it if you like. Nothing's going to happen to you. Hematite is a simple iron oxide. You can really do no harm to you. And so imagine if half of the batteries becomes something not so dangerous or not so harmful. So we published this story in an adequate paper, and we also obtained a national patent in Bosnia. Our method was, of course, original, very cheap and economical, so we did submit and obtain the patent. So I had a good question from some colleague, oh, did you patent it in the European Union? And I said, no, iron mine is only in Bosnia at this moment, so I just need my patent in Bosnia. So this was very good news. And I'm just going to show you one more short story. Again, one of the stories that we have presented to our colleagues when they visited us this summer. It is a story about the nanotechnologies in kaolinite. Kaolinite. Kaolinite is a material which is a plaster, it's a clay, you might have heard about it. And again, of course, we are taking interest into it because we have it a lot. We had 110 million tons of kaolinite on the north of Bosnia, around River Sava, which is flowing from Croatia and the northern Bosnia. So we do have a large deposit. This deposit was used for production of the very fine ceramics before, but now kaolinite is becoming much more than just ceramics. So I'm showing here the case of the factory with whom we collaborate in this research, and our colleagues with Alberto also have visited it. It's a very state-of-the-art factory producing facades. Okay, so paints for the houses. Facades are of course necessary more and more. There's a construction work all around the world, and this factory is already internationally present. But to be competitive in the facades industry, you need something original. So I'm here prizing the Italian discoveries of the stories of the ecological facades, eco-facades, how they are called. So what is the story about eco-facades? The facades that should actually purify the air. They should clean, they should dissolve or degrade toxic molecules present in the air, usually caused by human, as we know. So if these toxic molecules from the atmosphere jump into the eco-facade that we produce, there is always UV light from sun coming, and catalytically these molecules could degrade. So it's a lovely story. We don't know how big these effects are, but they are scientifically proven. And it would be interesting to have cheap, available eco-facades everywhere, wouldn't it? So we are trying to develop our own. Usually these technologies go as simply as just adding titanium dioxide into the powder. And the powder is usually kaolinite. The filler, the filling material of the facades is very usually kaolinite. So what we did actually in our country is this study of the Bosnian kaolinite. We are in the very early phase with kaolinite. You see the images of my assistant Maria. You can meet her there in the fair or here in this line. So this is Maria's master thesis. At this moment, Maria is actually doing something related to the geopolymers from kaolinite, but she has done a very nice characterization of the kaolinite that we have in Bosnia. And on the basis of her data and some data for some other materials, we are going to continue with this story of ecofacades. So even less than 1% of titanium dioxide into the facade mass can help a lot to have these catalytic effects. So instead of kaolinite, for this moment, the best results we have is with material called pyrophyllite. I'm going to kill you with my stories about millions of tons of this or that in Bosnia, but I hope you will remember. So pyrophyllite is also one wonderful clay. Pyrophyllite, the largest deposit in the world, is again in Bosnia, actually in Herzegovina. I have to be careful because it's on the south of our country. We have 38 million tons of deposit in the city of Konjic. And this deposit at this moment is there is some research concession. So this is not a living mine, but there is a permission for research. And that's what we actually did. We have some very, very fine data about this pyrophyllite. So this graphicon that you see above is so-called XRD. This is a Röntgen crystallinity check of this material, which we actually treated with some special combinations of acids, etc. And what we actually did is not that we add titanium dioxide into the mixture of facade, but we profited from the fact that there is titanium dioxide inside already. So we just uncovered it. We opened it up a little, that structure of pyrophyllite, so that titanium dioxide comes out. And this is clearly proven with this XRD data. Of course, we hypothesize about the same thing like our Italian colleagues or any other person who works with ecofacade, that it's going to have these wonderful effects. So this idea, since we had so much data, it was submitted to the very nice competition last year, and it won a Balkanese prize for the best university innovation idea. It was in competition of 183 teams and 6 prizes. So you see my students, Dragana and Sunčita above, they won not just a prize, but it was 5,000 euro. So it was good for them, of course. We were in the final year of their school, so it was a very prestigious thing and still useful. So we continue. This is the stage where we are. We continue with these studies. So what I will hope that you will bring from my lecture today is this story about the necessity of mining. We do have to have mines around Europe, not just in Bosnia. We can't do it all. We're just 4 million people. So please advocate for opening the mines and still keeping them green. Mines can be green if it's carefully managed, if it's a serious approach of young engineers and people who work there. Mines can really reduce the pollution to the absolute minimum. And then in few decades, Europe is going to be again 100% self-sustainable, both in terms of metallurgical materials or nanotechnologies. But until then, Bosnia will probably become a hub of nanotechnology in Europe. So you will come to us. I thank you very much, dear friends, and I hope I wasn't too long or slow, but nevertheless, I'm open also for questions now or later, if you like. Thank you.
So are there questions from the audience? Don't you have been inspired by this very enthusiastic presentation? I should have been younger. I would come studying in Bosnia or in Japan.
Thank you.
So there is a question over there. Just a second, I'll bring you the microphone.
So my question would be, you mentioned these decontamination of the air using the titanium dioxide coating, and I saw that you have sort of a graphic there, but what happens to the nitrogen part? So it had like a NOx and then an arrow, and it became somehow carbon dioxide and water. What really happens there? What's the mechanism, right?
That was a good question, and you were watching my graphs very well. With nitrogen oxide, it's not so difficult story. Of course, this catalytic effect is practically helping it out to dissolve as much as possible into native nitrogen, which is N2, and which is about, I think, 70% or so in the air. So that's not such a complicated story with nitrogen oxide, which are for sure part of the pollution story, but there are also always, toxic organic molecules present in the air, especially in the area where maybe the wood is still burnt, etc., or near to the chemical factories, etc. So even larger molecules could potentially be dissolved into smaller ones. So we'll see. We are going to make a little chamber. Now we have this project with the chamber. We're going to make the chamber, and we are going to connect it to the mass spectrometer to really measure the effects. We're going to have a little plate with our facade, injecting toxic gases and checking out what's coming out. Thank you. It was a very mature question for a young person. Thank you so much.
He doesn't look like a student.
He's a pupil from Hungary. I remember him. Excellent.
So nice.
Thank
I
you.
really appreciate this attention on the environmental
Yes.
side of the question.
Thank you. Oh, he can come to Banja Luka to study. I keep the chamber for you. We wait for you.
Are there other questions
Anything else?
for Suzana?
Thank you very much for listening.
So I think we can, Alberto, do you agree? We can proceed with the next.